Three, two, three, two, one, go. Hey, my name is Norman Laba, and today I'm going to be presenting live simulation. So, what was the purpose of this project? It was to answer this question: can you put creatures with tiny, simple, random, configured brain in a complex world, give them a criteria for survival, and see smart behavior emerge? So this project was inspired by a project on YouTube by a guy called David. So he built a project where he puts little creatures in a world, and over time he gave them a criteria for survival. And over time they became complex and they were able to survive and evolve. And so I had only about 15 hours to finish this project. It was inspired by the hackathon that I just attended when I realized that you can do a lot in a short period of time. So I gave myself 15 hours to try and do it. And so here's the demo of the project. Um, so when I run it, as you can see all these creatures moving around in random directions, and that's just because of their random configured brain at the very beginning. After about 100 simulation rounds, I kill half of them, and I use the survivors to restart the simulation. So the whole point was, if you use those who survived before, over time you're gonna allow them to evolve, right? Because you're passing better genes to the next generation. But after running the simulation for about 100 generations, they don't get any better. They do not learn how to survive. But let's explore how their brains are configured and maybe why that is. So here's their brain anatomy. So they have sensory inputs, which I categorize them into categories. I have internal inputs and I have external inputs. The internal inputs just tells you about the internal state of the creature, and the external input just tells you about the world of the creature, where the creature is, right? And the sensory inputs connect to internal neurons, which connect to output or action neurons. And output or action neurons could also be categorized in two categories. You can have internal output or external output. Internal output changes the internal state of the creature. External output changes the world in one way or another. So it includes things like movement and stuff. And then with your internal neurons, it took me a long time to be able to try and understand them. I still don't understand them very well, but what I understand with them is that the more internal neurons you have, the more layers you can have. And the more layers you have, the deeper the thinking of the creatures, right? And so internal neurons can connect to other internal neurons, but they can also connect to themselves, creating some kind of short term memory. And here's the structure of the gene. You have two neurons connected to each other. So you have a source, which could be either an internal or input neuron, which has an output value between -1 to 1. And then you have a sink, which could be an output or internal neuron, and have a weighted connection of between -4 to 4. So there's a random calculated value at the beginning of the simulation. And then genes is just a list. I mean, a genome is just a list of genes that the creature will have. Initially, they had about 4 genes, but on the simulation that I was running, they had about, I think, 8 genes. I doubled it because when it's 4, they don't move much. And so here's an example of, let's look at this like example brain to see how I calculate the output of each creature. So as you can see, I have 3 sensory input that I use as an example. You have A, B, C, and then you have an internal neurons X and Y, and then you have 3 output neurons 1, 2, 3. So and these values are the weighted connections, and this is an output value of C that is calculated during a simulation round. Um, and then each how I calculate the output of each neuron is I take the sum of all inputs, I pass it through a tangent function, and then it gives me a value between -1 and 1. And so then the next step was to do layering and forward propagation. This was the most difficult part for me because I didn't understand neural networks before, but here's how I did it. So the first layer will be all the sensory input, and then the second layer will be all the neurons that depend on the sensory input, and then the third layer will be all the neurons that depend on the second layer, and I'll keep on doing this until there are no neurons that depend on the previous layer. And so, what were the challenges and limitations? So, at the end, I didn't have a fully working application. The project was not complete because I didn't have external sensory input. And also, I had no prior knowledge of how neural networks work. I had a hard time trying to understand layering, topological sorting, and fault propagation, and why this matters. Um, so I had been meaning to do this project since high school. I saw the YouTube video when I was in high school, but I didn't understand anything in there. I was just like curious about how it works, and I've always wanted to replicate it. So finally, I have a little bit of understanding of how it works, and I just wanted to challenge myself. And also, I was able to prove to myself that you can do a lot in 15 hours if you just force yourself to focus. I wasn't able to finish the project, but I mean, I just like learned that you can do a lot, and it was also fun to learn a lot of things under pressure. And so this is not the end. I want to do another sprint next month where I will try and finish the project, and I'll focus on things like enabling more intelligent behavior. I'll add imitation, which is important for evolution. I'll play around with the more interesting ideas. And yeah, so thank you so much for listening. Yeah. Away,